Mariner 1. In July 1962, NASA launched its first ever mission to another planet. The Mariner 1 spacecraft lifted off from Cape Canaveral, aimed at Venus, carrying years of engineering work and a fortune in taxpayer funding. Everything looked normal for the first minute of flight. Then, 293 seconds after launch, a safety officer made the call to destroy the rocket midair. It exploded over the Atlantic Ocean. At first, nobody understood what had gone wrong. The rocket was healthy. The engines were fine. So why did it veer off course so badly that it had to be blown up before it endangered ships or land? Investigators traced it back to the guidance code. Somewhere in the process of writing out the equations by hand and transcribing them into the rocket's program, a single small mark above one symbol had been left out. That tiny missing mark told the computer to treat completely normal, minor fluctuations in the tracking signal as if they were dangerous course deviations. The rocket kept correcting for a problem that didn't exist until it was pointed in the wrong direction entirely. One overlooked symbol, smaller than a single character, destroyed a multi-million-dollar spacecraft in under 5 minutes. It's remembered today as one of the most expensive punctuation-level mistakes in history, the Gimli Glider. On July 23, 1983, an Air Canada Boeing 767 took off from Montreal, bound for Edmonton. Partway through the flight, at 41,000 feet, the plane's engines shut down, both of them. The pilots were suddenly flying a 132-ton airliner with no power at all. The cause traced back to the ground, hours earlier. The plane's fuel gauge system wasn't working properly, so the ground crew had to calculate the required fuel manually. The aircraft was one of the airline's first to use the metric system, meaning fuel needed to be measured in kilograms. But the conversion factor used by the crew that day was for pounds, not kilograms. The math looked correct. The numbers on paper matched what the crew expected to see. In reality, the plane had been loaded with less than half the fuel it needed to complete the trip. With no engines and no power for most instruments, the captain, who also happened to be an experienced glider pilot, glided the aircraft toward the nearest usable runway he could think of, a decommissioned Air Force base in Gimli, Manitoba, which had since been converted into a go-kart racetrack. He landed the powerless jet safely, with people and vehicles still on the strip. Everyone on board survived. The investigation blamed the mixed use of two measurement systems during a rocky transition period, and airlines worldwide tightened their fueling procedures afterward. Chernobyl. On April 26, 1986, operators at the Chernobyl nuclear power plant in Soviet Ukraine were running a late-night safety test on Reactor 4. The test was meant to check whether the plant could keep cooling systems running for a few seconds during a power failure before backup generators kicked in. To run the test, several of the reactor's automatic safety systems were deliberately switched off, standard procedure for that specific kind of test. But the test also ended up leaving the reactor running in a dangerously unstable low-power state for far longer than planned, a condition the reactor's design handled very poorly. When operators tried to shut the reactor down using the emergency button, a design flaw in the control rods caused a sudden power spike instead of a shutdown. Within seconds, the reactor's core overheated and triggered a catastrophic explosion, releasing radioactive material across the surrounding region and, in trace amounts, across parts of Europe. The event remains one of the two INES Level 7 nuclear disasters ever recorded, alongside Fukushima, and led to sweeping changes in international reactor safety design. Piper Alpha. On July 6, 1988, the Piper Alpha oil platform was operating normally in the North Sea, about 120 miles off the coast of Scotland. It was one of the busiest production platforms in the region. By the end of that night, it would become the deadliest offshore oil disaster in history. Earlier that day, maintenance workers had removed a pressure safety valve from one of the platform's condensate pumps to service it, and temporarily sealed the opening with a simple metal disc called a blind flange. The paperwork for this job, called a permit, was filled out correctly. The problem was where it ended up. Instead of being placed where the night shift would see it, it was left in a different location, and the outgoing team's handover to the incoming night crew didn't flag it clearly. Later that evening, the platform's main condensate pump broke down. Following standard procedure, the night crew looked for a backup pump to bring online, the exact one that had just had its safety valve removed that morning. They checked for a permit blocking its use, found nothing telling them not to, and switched it on. Gas began leaking from the spot where the valve should have been, and within minutes, it ignited. The explosion set off a chain reaction that destroyed the platform. 167 people died that night. The disaster led to a complete overhaul of offshore safety regulation in the UK, particularly around how permit-to-work systems are documented, centralized, and handed between shifts. Apollo 13. On April 13, 1970, 3 astronauts were roughly 200,000 miles from Earth, 2 days into a mission to land on the moon, when they heard a loud bang and felt the spacecraft shudder. Warning lights lit up across the cabin. One of their oxygen tanks had just exploded. The root cause traced back to months before launch, during a routine ground test. That particular oxygen tank had an internal heater controlled by a thermostat switch, designed to run on the spacecraft's normal voltage. But at some point during testing on the ground, the tank was connected to a different power supply that used a higher voltage than it was built for. The mismatch caused the thermostat switch inside the tank to weld itself shut, and during a later test, the heater ran far hotter and longer than it should have, quietly damaging the insulation on the wiring inside the tank without anyone knowing. That damaged wiring sat there unnoticed for months, until the moment in space when a routine stir of the tank's contents caused a spark, igniting the exposed insulation and rupturing the tank. With their main oxygen supply gone and the spacecraft losing power, the astronauts and mission control worked together for 4 tense days, using the lunar lander as a lifeboat to get everyone home safely. All 3 astronauts survived, and the mission became one of NASA's most well-known examples of crisis management under pressure. The investigation afterward led directly to a redesign of oxygen tank components and much stricter control over testing procedures and voltage compatibility for spacecraft hardware. The Knight Capital Trading Glitch. On the morning of August 1st, 2012, Knight Capital Group, one of the largest trading firms on Wall Street, rolled out a routine software update to its automated trading system, meant to prepare it for a new stock exchange program launching that day. The update was supposed to be installed on 8 servers. 7 were updated correctly. On the 8th, the new code was added, but an old, unused piece of trading software from nearly a decade earlier, one the company thought had been fully retired, was never actually removed from that machine. When the markets opened at 9:30 a.m., that old dormant code was accidentally reactivated. It began firing off a flood of unintended stock trades, buying and selling shares with no limit and no one at the controls. For 45 straight minutes, while engineers scrambled to figure out what was happening, the system executed millions of trades across more than 150 different stocks, moving billions of dollars in unwanted positions. By the time it was finally shut down, Knight Capital had lost close to $440 million, nearly its entire value as a company. It was acquired by a rival firm within days. The incident remains one of the most cited case studies in the finance industry